Today what we're going to do is we're going to finish up the substitution, so I'm going to be muting this a lot because there's going to be a lot that I want you all to attempt while we're all here together with the U substitution. So we're going to start with some derivatives, and you'll notice that in the derivatives we have to use the chain rule. So with the U substitution, it pretty much is almost always reversing the chain rule. When we take a look at our first one, is anyone willing to give me the answer that they have either in the chat or unmuting themselves? The answer they have for number 1, finding the derivative of sine 2x squared. Is anyone willing to unmute or type in the chat what they got for the very first one? Okay, so our very first one then is y prime is equal to, remember I'm doing d theta of the sine of theta is equal to the cosine of theta multiplied by the derivative of the angle theta. And so it's going to be 4x because that is the derivative of the angle, the cosine of 2x squared. Does anyone have questions on that one? What about the second one? Does anyone have the answer to the second one that they are willing to either unmute themselves and or to just type in the chat? The derivative for the second one, y prime for the second one. All right, so for the second one, what you all are using is du of the natural log of u is equal to 1 over u multiplied by u prime. So we end up with the derivative of the x squared plus 1 is 2x. So that will end up being in the numerator when you clean it up. And then in the denominator, you're going to have x squared plus 1. Does anyone have any questions on that one? Okay, cool. Looking at the last one, what we have for the last one is the product rule that's going on. So the last one, y prime here, I do have to use the product rule on the second term. And does anyone have the answer for the second one? They're willing to type in or unmute themselves to let me know what they got for the second one. When we are doing the third one, the first part is pretty straightforward. This part's pretty straightforward. It's just going to give me 2x. But with this one, I have to do the uv. So it is a multiplication of x multiplied by cosine x. So when I do the derivative, d, we'll do it this way. Instead of d, we'll just do it with u v prime. Then this is going to be u prime v plus v prime u. So I do have to use the product rule. And so I have the derivative of x is just 1, so that's going to be plus the cosine of x. And what I'm doing here, this is v, and then u prime, where u prime up here is 1. v prime is negative sine x. So I'm using the product rule. And so then I'm going to have minus, the derivative of cosine is negative sine, that's why it's a minus, the sine x, and then I'm multiplying by x, or I could write the x first. And the order here does not matter, so I could have wrote this as y is equal to 2x plus cosine x minus x sine x, or equivalently I could have done 2x minus x sine x plus cosine x. Those are the same thing, so it would not have mattered the order that I wrote them. What did matter is that I did the product rule. So because this is a multiplication, I do have to do the product rule between x and cosine x. So with that said, let's go back to where we were, which is in U substitution. I believe we did these 4 yesterday when we met. Now we're going to take a look at these down here. Now all of these are pretty well, I can't say they're straightforward, but I am going to do P because I need to show you what happens when you have to adjust for the limits of integration. So I'm actually going to do P. And with P, Whenever I see a power here, then that means I probably have to use U substitution, and in particular, what usually happens is U is on the inside. So even if it would have been wrote like this, as an example, if it would have been wrote from 0 to 2 of 2x, x squared plus 1, the quantity squared, dx, as an example, then I still would have used this portion probably to be the U substitution. So that's not where we are, though. We are right here. So the first thing I'm going to do is say let U equal. And I'm going to let it equal what the value is inside of the parentheses. So I'm going to let U equal x squared plus 1. So then du is going to equal 2x dx. Now I have a replacement for this. I replaced that with U. I'm going to replace this part with du. But I also need to deal with these limits of integration because I don't want to have to go back and resubstitute. And I don't want to write it as u1, u2, u sub 1, u sub 2. So if I take a look right here, when x is equal to 0, then u must be 0 squared plus 1. So u becomes 1. That is my lower limit. So this becomes 1 when I do my u substitution. When x is equal to 2, then that tells me that u is equal to 2 squared plus 1, so u must equal 5. So this gets replaced with 5. Now I'm going to stop a minute before I write it all completely. I want you to ask me, what kind of questions do you have so far on this? What we're now going to do is we're going to rewrite it with the u substitution and the limits of integration changing. So I'm going to rewrite this as 1 to 5 of 1 over u squared du. Now, because the power is not 1, I know it's not going to integrate to the natural log. If this would have been 1 over u du, then I know I would have integrated to the natural log, but it's not. It's 1 over u squared. So I'm just going to rewrite this as 1 to 5 of u to the negative 2 du. And then I'm going to do my usual integration. I'm going to add a power and then divide by that value. So I'm going to add a power here. So I'm going to add plus 1 here to remind myself I also need to divide by that. So this is going to equal u raised to the negative 1 divided by that new power, which is negative 1, and evaluated from 1 to 5. So what I have then is I have negative 1 over u evaluated from 1 to 5. Because u raised to the negative 1, what I'm using is a raised to the negative n is 1 over a to the n. So then I start with my upper limit first. I'm going to evaluate with my upper limit. So this is going to equal to negative 1 over 5 minus a negative 1 over 1. So I end up with negative 1/5 plus 1. And my final answer is 4/5. And that is my final answer. What kind of questions do you have for me? What kind of questions do you have?
U equal the cosec because that was what was being squared.
Okay.
And then I let du equal sine x dx.
You said negative, right? Negative.
Yeah, negative.
Okay. So do I see a negative there in the original integration?
No.
How do I adjust for that?
We can make it not sure.
That's okay. So I need to get the negative away from there. So what I'm going to do is I'm going to think about it as multiplying both sides by a negative or dividing both sides by a negative. So my replacement is going to be negative du is going to replace the sine x dx. So this gets replaced with a negative du. And then this, of course, gets replaced with a u. Did you have a chance to change your limits of integration then? When
Yeah, I plugged in pi over 4 and 0 to cos x.
Okay. So when
Because
x...
that's the u.
Yep.
And I got square root 2 over 2 and 1. But then I was looking back at the previous problem and was a little confused where we got 1 over u squared du.
Okay.
After we changed the limits of the integration, so I couldn't really go any further because I wasn't sure.
Okay. So what we have now is we now have the limits of integration changed from 0 to 1 and pi over 4 to the square root of 2 over 2. And I have 1 over u squared, and then I'm going to adjust the negative by just pulling that out front. So did you get to this far?
No, because I wasn't sure, like, do we just always put 1 over u squared? Like, I wasn't sure where that number came from.
Okay, good. Good. Thanks for clarifying that. So I'm gonna move the screen up so you can see the previous one and this one and how they are aligned. If I rewrite this as the integral from 0 to 2 of 1 over x squared plus 1, the quantity squared, multiplied by 2x dx, does that make it a little clearer why it's 1 over u squared?
Yes, because then you would put the u in for x squared plus 1.
Yep. And so something similar is happening here is when I go from 0 to pi over 4, I can rewrite this as 1 over the cosine x squared and then sine x dx, like that. Really poorly wrote. How is that? Is that better?
Yes, thank you.
And then before I let you go and have you finish this with me, the question is, why is it negative? And that's because the derivative, so when I'm asked to find d theta of the cosine of theta, this is always equal to the negative sine theta and then multiplied by the derivative of theta. And that's how come I have a negative. So when I did the cosine of x, it is always going to be the negative of the sine of x. And I'll show you a picture in a minute. I'll show you why this has to work out that way. All right, so going back to this one, now what do I do? Maddie?
Then you would take the derivative.
The antiderivative, yeah. So when we do the antiderivative of it, what does the antiderivative become then?
U negative 1 over negative 1.
Evaluated from 1 to square root of 2 over 2. Don't forget that negative there. Now what?
I'm still catching up on before.
That's okay. Everyone is. So I'm totally fine just kind of hanging. I wanted to make sure that you've seen how the limits of integration need to change. So that's why we're starting with this one, and then all the rest of it's just practicing u substitution. So if it takes us a few minutes to get through this one's totally fine. So I know it's going to be negative, and then I'm going to just write 1 over, because that's the same thing as u raised to the negative 1. What's my first value I need to put in?
Square root 2 over 2.
And then minus a negative, and then what's the second value I need to put in?
1.
Okay. So I end up with, when you get done, I'm going to use this rule that if I have 1 over a over b, that this is the same thing as b over a. That's what I'm going to do for this part of it. And so you're going to end up with a negative, and then it's going to be 2 over the square root of 2, and then double negatives make that plus. However, that negative 2 over square root of 2 simplifies just the negative square root of 2 plus 1. And that's my final answer, and I can leave it like that, or I can get my calculator out and get the equivalent. How was that one? How are we doing? So when we are here, the question is, why isn't it positive? Oh, yes, it is positive. Thank you. Because I forgot I had the negative out front. Thank you for catching that. So this negative here makes that a double positive. So that's positive and that's positive. So it ends up being a positive, and then it's going to be subtracting. Thank you for catching that. Cool. And then it's going to be a minus here, and then that's going to be a plus. Yep. Thank you for catching that. It's because the fact that we had here. Oh, what is happening? I hate it when it does this. I need to do. Here we go. So what's happened? Sons of guns. If I were to be able to scroll up without destroying this, it would have had a negative on the outside, so it ends up becoming a positive 1 over u. And that's why we end up with the square root of 2 minus 1. And son of a gun. Son of a gun. Let me do it, see if I can do a quick save here. Let me pause this. Okay, so let's see if I can do it. No. All right. Anyways. Do you have any questions before we go back to some of the other ones with the practice? Do you have any questions on this? Any other questions you have for this? And thanks for catching that, Cole. Okay, so if there's no other questions, then I'm going to erase a lot of this so that it's not being too much of a pain. And we're going to go back up to these up here so we can get some more practice without changing the limits of integration. Okay, we did D. Okay, so I want you to do E, F, and G and be prepared to walk me through these. So I'm going to put this on pause, and we're going to spend some time doing E, F, and G. As a little hint for this one, I would rewrite this one as the sine, an integration of the sine of theta raised to the 10th power cosine theta d theta. That's how I would write that one. So just going to discuss where we are now is my initial reaction on G is to put u to be the denominator part, y plus 1. So if I let u equal y plus 1, then du equals dy. And now I've got a replacement for dy, and I have a replacement for y plus 1 to the 4th. What I don't have a replacement for is y squared. But if I take u and I say u is equal to y plus 1, that means y itself must have been u minus 1. Now that's not going to change the derivative at all. As you can see, my derivative is still going to just be dy du. dy equals du, or du equals dy. So that doesn't change the derivative by moving the constant to the other side of the equal sign. What it does do is it allows me to say I know I can replace y squared with u minus 1 and then square it. And I'm actually going to go ahead and do the multiplication out on this, because otherwise I'm going to have u minus 1 squared over u to the 4th, and that didn't seem to help me much. So I'm going to go ahead and multiply this through, and I'm going to get u squared minus 2u plus 1. So in the numerator, I'm going to get u squared minus 2u plus 1. And the reason I'm doing that is because I'm going to use this algebra rule that says if I have a plus b over c, then I can write this as a over c plus b over c. And that allows me to put u to the 4th under each one of those terms. So this is going to be equal to u squared over u to the 4th minus 2u over u to the 4th plus 1 over u to the 4th du. Then that allows me to write this as u raised to the negative 2, because I'm going to subtract the powers up. So when I'm using this rule right here that says if I have a to the m over a to the n, then this is a to the m minus n. I am subtracting the exponents. So this is going to be u to the negative 2 minus 2u to the negative 3 plus u to the negative 4 du. Now I'm going to stop. I'm going to ask, what kind of questions do you have for me so far? So once I've wrote it in that manner, then what I can do is I can go ahead and integrate each an individual term by using my power rules. So the first one is going to be u raised to the negative 1 divided by negative 1. My second one is going to be negative 2u raised to the negative 2 divided by negative 2. And then my last one is going to be, I hate it when I touch that. My last one is going to be plus u raised to the negative 3 divided by negative 3. And again, what I'm doing is I'm adding a power here each time when I integrate and then dividing by that new power. And then don't forget the plus c. So remember, I am not solving, or I didn't start out with u, I started out with y plus 1. So everywhere I see u, I need to replace back with y plus 1. So this is going to be equal to negative 1 over y plus 1. These 2's are both negative and they're going to cancel themselves out. Double negatives make that positive. So that's going to be plus 1 over y plus 1, the quantity squared. And then minus 1 over 3 y plus 1 cubed, and then plus c. And that is my final answer for G. What kind of questions do you have for me? I'm going to go ahead and still have the denominator be u. So that's still going to be u. I'm going to let u equal x minus 2. That means du is equal to dx. So where I'm at this point is I'm at the integral from, I have u in the denominator and I have du. I still have this problem child here just like I did with g. So I'm going to take my let u equal and I'm going to solve for x. So u plus 2 is equal to x. Just like I did with g, that allows me to replace this x right here with u plus 2. I don't have to multiply it through though. So my numerator is going to be u plus 2. And then I'm going to do the same thing as I did in g, is I'm going to use this rule that says if I have a plus b over c, then I can write this as a over c plus b over c. So then this is going to be equal to the integral of 1 plus 2 over u du. And then I'm just going to rewrite it with my, actually, you know what? I'm going to put that extra step in there that I dropped. Probably should put that in there. Sorry. This is u over u plus 2 over u, which is equal to the integral of 1 plus 2 raised to the negative 1 du. And then now whenever I see the 1 over u in the integral part, or u raised to the negative 1, then when I see this, I know I'm going to, when I do the integration of this, my antiderivative would be the natural log of the absolute value of u. So I'm going to still see the natural log, but it's only going to be on part of it. So I integrate 1, and that just gives me x. Whenever I see 1 as or any constant, it's going to be the constant times x. And then it's going to be plus 2 the natural log. Actually, I'm still in u's. Sorry, I should probably still stay in u's. So stay in u's. And then 2 the natural log of the absolute value of u plus c. which is u was x minus 2, so it is x minus 2 plus 2, the natural log of the absolute value of x minus 2, plus c, and that's my final answer. How was that? I'll wait for it. I've got a leg on the screen, so just wait for that to catch up to the rest of us. And there's my final answer. How was that? Okay, I know we're almost out of time, so I'm just going to do H really fast. And like I said, while we were working on F, that we're going to let that be U. So let U equal e to the x plus e raised to the negative x. Then du is going to give me e to the x minus e to the negative x dx. So even though my reaction may have been, hey, I want to do u is equal to e to the x, whenever I see a denominator, I almost always make that the u. And then by doing that, I have a replacement for the numerator and dx to be du. And so this becomes the integral of 1 over u du, which when I see 1 over u, it is the natural log of u plus c. So my final answer on H is the natural log of the absolute value of e to the x plus e raised to the negative x plus c. And in particular, e to the x is never going to be a negative number. E raised to the negative x is never going to be a negative number. So I could, if I desired, take off the absolute value part because these two are never going to be negative. And that's my final answer. And that is not an E, that is a C. That is a C. It's a little bit better. All right. Does anyone have any questions on H? Anyone have any questions on H? This is my final answer on H. I is going to be similar to what G and F were like in all of their glory. If you have no other questions, then we are done with U substitution, and we will start 1.6 tomorrow. Have a great afternoon. Hopefully this weather will get better, and we will speak to you all tomorrow. Remember, I have office hour between 12:30 and 2 o'clock every day. If you can't make that, go ahead and shoot me an email about when you would like to meet if those meeting times do not meet with you, if that doesn't work out for you. Otherwise, have a great afternoon and the rest of your day, and we will speak to you all tomorrow.